Hello everyone, I'm academician Dr. Lilia. Welcome to Science and Me YouTube channel. The mission of my channel is to introduce you to popular science and to create a popular science encyclopedia on YouTube. We are back with an interesting popular science video. I would be very happy if you support me by subscribing to my channel and writing a comment. If you are ready, let's start the video. Holography is a technique that allows the creation of three-dimensional 3D images using the principles of interference and diffraction of light. Unlike traditional photography, which captures only the intensity and color of light, holography records both the intensity and phase of light waves. This additional phase information enables the reconstruction of 3D images that appear to have depth and parallax, similar to how objects appear in the real world. Holography is a technique that enables a wavefront to be recorded and later reconstructed. It is best known as a method of generating real three-dimensional images, but also has a wide range of other applications. In principle, it is possible to make a hologram for any type of wave, including sound waves, light waves, and even matter waves. Here's a brief overview of how holography works. Holography works by recording the interference pattern between two beams of light, a coherent reference beam and a scattered beam from the object being holographed. The interference pattern contains all of the information necessary to reconstruct the wavefront of the object, which can then be used to create a three-dimensional image of the object. Recording. To create a hologram, a laser beam is split into two parts. One part, called the reference beam, is directed onto a photosensitive recording medium, such as a holographic plate or photosensitive film. The other part, called the object beam, is directed at the object you want to capture in 3D. To reconstruct a hologram, it is illuminated with a coherent light source, such as a laser. The light diffracts from the hologram and reconstructs the wavefront of the original object, creating a three-dimensional image. Interference. The object beam interacts with the object and carries information about the object's shape and structure. When the object beam and the reference beam intersect on the recording medium, they create an interference pattern. This pattern is formed due to the phase differences between the two beams. Exposure. The recording medium captures this interference pattern as a series of dark and light fringes, which encode the 3D information about the object. Development. The holographic plate or film is then developed, similar to traditional photography, to reveal the recorded interference pattern. Reconstruction. To view the 3D holographic image, a laser beam is shown onto the developed hologram at the same angle as the reference beam used during recording. When the laser light interacts with the hologram, it diffracts off the recorded interference pattern, causing the 3D image to appear in space. Key characteristics of holography include parallax. Holograms display different perspectives of the object as you move around them, just like real objects. Depth perception. Holograms give the illusion of depth and can appear to have a floating quality. High resolution. Holograms can capture fine details and provide a high level of realism. Holography has a wide range of applications, including three-dimensional imaging. Holograms are used to create three-dimensional images for a variety of applications, including entertainment, education, and medicine. Security. Holograms are used on security features, such as credit cards and banknotes, to prevent counterfeiting. Data storage. Holograms can be used to store large amounts of data in a very small space. Microscopy. Holography can be used to create high-resolution three-dimensional images of microscopic objects. Manufacturing. Holography can be used to create precise molds and templates for manufacturing. Holography is a rapidly developing field with many new and exciting applications. As holography technology continues to improve, it is likely to have a major impact on many different industries. Here are some examples of current and potential applications of holography. Holographic displays. Holographic displays can be used to create realistic three-dimensional images that can be viewed from any angle. This technology has the potential to revolutionize the way we interact with computers and other devices. Holographic microscopy. Holographic microscopy can be used to create high-resolution three-dimensional images of cells and other biological specimens. This technology has the potential to lead to new discoveries in biology and medicine. Holographic storage. Holographic storage can be used to store large amounts of data in a very small space. This technology has the potential to revolutionize the way we store and access data. Holographic manufacturing. Holographic manufacturing can be used to create precise molds and templates for manufacturing. This technology has the potential to improve the quality and efficiency of manufacturing processes. Holography is a powerful technology with the potential to have a major impact on many different industries. As holography technology continues to improve, it is likely to become even more widely used in the future. Holography has various applications, including art and entertainment, data storage, security, such as holographic seals on documents or products, and scientific research. It has also been used in fields like medicine for 3D visualization of objects or tissues and in engineering for non-destructive testing of objects. Additionally, holography continues to be an area of research and development with potential applications in augmented reality and virtual reality displays.